In this video, we'll talk about how we name substituted alkanes. So the first thing we need to do is find the longest parent chain in our molecule, and then we're going to number the carbons in the chain from the end that is closest to our first substituent. And then if we have more than one substituent, we will list those in the order alphabetically with a number to designate which carbon that they are on. So let's first identify the parent chain. Sometimes you might think that it's easier to just go left to right, or right to left, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, let's make sure that that is the longest chain. We could also go 1, 2, 3, 4, 5, 6, 7, 8. Well, that's not the longest chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is actually the longest chain. So my point here is that the longest parent chain may not always be a nice linear line. You always need to try all your different options to make sure that the longest parent chain is selected. It may or may not be a linear straight chain. Now we're going to number our carbon atoms from the end closest to the first substituent. So for instance, when we're doing this one, we could number it 1, 2, 3, 4, 5, 6, 7, or we could number it 1, 2, 3, 4, 5, 6, 7. We want to begin numbering from the right because we would go 1, 2, 3 to get to my first substituent, as opposed to 1, 2, 3, 4, 5 to get to my first substituent. Okay, so always choose carbon number 1 as the end closest to your first substituent. Here's another example involving numbering. We could go 1, 2, 3, 4, or we could go 1, 2, 3. So in this example, we're actually going to number from the left. So just try all your options. Okay, you can't just assume that the first numbering system you come up with is necessarily the correct one. You need to try it from both ends of the molecule and choose the one that gets you to your first substituent first. Now we're going to state where the substituents are located. Okay, we're going to use those as prefixes. And we're going to put a number to designate where that substituent is. Numbers will be separated with hyphens and commas. So let's look at some examples. We started numbering from the right. Why? Because 1, 2 got me to my first substituent versus 1, 2, 3 or 1, 2, 3. So we began numbering from the right. Okay, so this is carbon 1, 2, 3, 4, 5, 6. So this is a hexane. And on carbon 2, there is a methyl group. A 1 carbon chain is called a methyl group. And a 2 carbon chain is called an ethyl group. E comes before M. So now all I need to do is tell my reader where my substituents are located. We put these in alphabetical order. So it's 4 ethyl. That's telling the reader that carbon 4 contains an ethyl group. Then we put a dash. 2 contains a methyl group. And then we just put the parent chain hexane. No space in between the two. All right, make sure you understand why it's 4 before 2. It's 4 before 2 because E comes before M. If the same substituent is on there more than once, we would just list the carbons that it's on and then use the prefix mono, di, tri, tetra, penta, etc. to designate how many. So for instance, 3,4-dimethyl-nonane tells the reader that carbon 3 and carbon 4 both have methyl groups. 4,4,6-triethyldecane tells the reader that carbon 4, and then there's another one on carbon 4, and then also carbon 6 all have ethyl groups. So here's an example. How do we begin numbering this one? All right, let's try our options. 1, 2, 3 gets me to this substituent on 3. 1, 2, 3 gets me to this substituent on 3. 1, 2 gets me to this substituent. So we actually began numbering from the left. Okay, so we're going left to right. 1, 2, 3, 4, 5, 6, 7. So that means it's a heptane as our parent chain. We've got a methyl group on carbon 2. We've got a methyl group on carbon 3. And we've got an ethyl group on carbon 5. What comes first? E comes before M. Okay? Don't let this throw you off. This di is just a prefix. M versus E is the differentiation you need to make. So E comes before M, so that's why it's 5-ethyl and dash. Now carbons 2 and 3 both have methyl groups. That's why it's 2, 3. And then there are 2 methyl groups, so that's why the di is there. And then the parent is heptane. So the final answer is 5-ethyl, 2,3-dimethyl, and then the parent chain is heptane. Okay, always put them in alphabetical order, and if the same substituent appears on more than one carbon, write which numbers they are on, separated by commas. Here's another example. Let's take a second, look at it on your own. We've got a lot going on here. See if you have an idea of what the correct answer is. I'll give you 5 seconds to think. Because this is a video, you can pause it if you need more time than that. Are you ready to see the answer? We began numbering from the bottom. 1, 2 gets me to my first substituent versus 1, 2, 3. That's why we began numbering from the bottom. Okay, so my parent chain is 1, 2, 3, 4, 5, 6, 7. We've got a methyl group on carbon 2. We've got an ethyl group on carbon 3. We've got another methyl group on 4, another methyl group on 5. So how do we write this out? Well, ethyl comes before methyl, right? So E, M, M, M. So 3-ethyl. Now we've got 3 methyl groups that we need to list in our name. So we'd say 2, 4, 5, trimethyl, and again this is a 7-carbon chain, so you'd say heptane. Always put them in alphabetical order and always state the number that the substituent is located on. We can also take a name and turn that into a structure. So for instance, if I say 2-methylpropane, I would draw a 3-carbon chain with a methyl group on carbon 2. So a 3-carbon chain with a methyl group on carbon 2. 2-methylpropane. Another example we could do, 6-ethyl, 3,4,5-trimethyl, nonane. All right, so how are we going to do this? We're going to draw a 9-carbon chain, and then when you're drawing it from scratch, you can decide which end you want to begin numbering from. That's up to you, because you're choosing how to draw this molecule. So draw a nonane, and then on carbon 6, put an ethyl group, and then carbons 3, 4, and 5 will all get methyl groups. If your substituent is a halogen, so in other words, a fluorine, a chlorine, or a bromine, we're going to call those bromo, fluoro, or chloro in our name of our molecule. So for instance, in this molecule, let's decide how we want to number it. Do we want to number 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, or 1, 2, 3. Now notice you can go either way. It's going to be an ethyl group either way. So I could go 1, 2, 3, 4, 5, 6 and have an ethyl group, or I could go 1, 2, 3, 4, 5, 6 and have an ethyl group. So either way it works the same. So this is an ethyl group, and this is a bromo group. So B comes before E. So it's 2-bromo, 4-ethyl hexane. And that's the name of that molecule. The rest of this, I think, can be determined pretty well from your notes. The best thing that you can do to get good at nomenclature is just practice. Practice, practice, practice. So I've got lots of problems on D2L for you to try. Answer keys are included, and the best way to get good at this is just repetition. But that's the basics of substituted alkane nomenclature.